tool is a depth micrometer. It measures the depth of something, okay? So here we're measuring the depth of, possibly it could be the valve or recess of a valve here. So you could be measuring inside, just how far inside the opening where the valve springs go. You can check the depth there. Because over time, just to remind you, right here is what composition on this is a cylinder off one of our larger Continentals, okay? And the top of the cylinder is made of what? Aluminum. Down here is steel, okay? And they're actually screwed together when they're manufactured, okay? Just similar metals, but they're pretty wild how they're screwed together. Every once in a while, you'll have a customer who comes in and they're leaking right here. We did have one customer that actually had one come off mid-air. The whole top of it came off. So it's rare, but it does happen. Okay? So you're checking the depth of a micrometer. He was totally fine. Airplane was fine. He just had to land in a hurry. Okay. Small hole gauge or a ball gauge. Okay, these are pretty cute little things. Called a ball gauge. Let me put it on the little big screen here. Okay. All right, so this would be where your valve goes, and to give you an idea of what I'm talking about, because some of you may have never had an engine apart. So this is a valve. Does anyone know or remember which valve is usually bigger on the head? Intake is head is bigger. Exhaust valve stem is bigger. Okay? So we'll talk about that sometime later of why exactly, but just remember the head of the intake. The head of the intake is bigger. Okay, you want cool air to get in there and cool off the cylinder. Okay. Okay. So then your valve set like so. Okay, and then as it's going along, as you're going along, the valves are opening. They're spring loaded. Okay, they're opening to allow cool air or fresh air in, which also has what with it, mixed with it? Fuel, because it's dropped on the intake side. So the intake opens, we get this amazing noise inside, kaboom, controlled combustion, explosion, combustion. And then it goes out the exhaust. Exhaust valve is smaller so that it doesn't come apart. Usually thicker, and then the stem's thicker because it gets so hot because all those gases are going around the valve, so it's typically smaller for that reason. They don't want it to come apart. Okay? So, now, your valves, over time, will wear, okay? Because they're constantly getting abused. So you'll measure, when we're required to do this, say we overhauled an engine. It's just sitting there. Okay, so over time, the valves will wear. We call it a wobble. So this one doesn't have very much. But then when we get to the other side here, we have quite a lot of wobble. Okay, quite a lot of wobble on your valve, and that's pretty typical after 2,000 hours to have wobble on the valve guide. And it will wobble this direction. It doesn't typically go this direction. It typically goes in the direction of the rocker arm, okay? So you're saying, well, all these turns, they're all new. That's okay. I'm just trying to show you what we're going to measure, building you up, okay? So now we're going to pop the valve out. Try. All right, now, see the valve guide there. So then we grab a ball gauge. As you tighten it, the ball gauge gets a little bit fatter, okay, as you tighten the back. Okay, so I'm tightening it, righty-tighty, lefty-loosey most of the time. Okay, righty-tighty there. Tighten it down until it gets a little snug. And what's interesting is to realize how much is worn, there's the same size. When we go this way, it goes right in. Because that's in the direction of the rockers. It goes in, and then right here, it won't go. It's getting held up. Okay? So it's worn. Well, how much is it worn? Does this give me a measurement? No. It's just a cute little ball gauge. So then I got to go to a precision measuring tool, which could be what, John? A micrometer. So you come over here and you grab what size micrometer you think it is?
0 to 1.
0 to 1. Okay? So rather than you having to watch me, why don't we take a candidate? Let's see who gets the blessing of volunteering. Here we go. Oh, Trevor, congratulations. Come on up. All right. So we're going to critique you rudely. Kindly, sorry. We want you to measure this ball gauge. Can everybody see you? Okay, good. All right, there you go. We're going to go ahead and measure that precisely. And you don't want to torque down on the ball gauge because then it's not an accurate reading. You want to gently use the ratchet part just to tighten it. Not just me, nobody else can see. Okay.
Oh. This is weird. How do you do that?
I don't do it very well.
Well, you can kind of see it's past 4. And you just trust me on that it's past the 25.
Okay, so we're...
And it's just over the 11. So you add the 25 plus 11. 36, yeah. Thank you. So it'll be 0.436. 4?
Well, I'm feeling a little sick.
Here, how about, I'm gonna get the 1.5 minus 4.
Hey, look at that, 4. Okay,
So whatever it says, I
so
can't remember.
4364.
Yeah.
0 point.
Yep.
All right.
4364.
All right, good deal. All right, so let's get another candidate up here. So now that we're going to switch to exhaust, okay, so we're going to go to that was exhaust. Let's go to intake. All right? Yes. Who's the next person? We're going to get you to come up here and do this real quick. Zach, don't leave, man. All right, Charlie, you're up. Charlie, come on down. Okay? All right, we want you to measure this one.
I'm never leaving.
So you're going to use the ball gauge. Let me mess it up real quick. Okay, it's messed up. I want you to use the ball gauge and then use the micrometer to read it. Okay? All right, go in the direction that it gets abused. So it's in the direction of the rocker. Here's your rocker going this direction here.
Okay, so my line is
You want to line up?
all
Yep.
up, not
Yep.
crap.
That's right.
All right,
Correct.
yeah.
And then make sure you're straight up and down. As straight as you can be. Oh, you're trying to hide it now. We're not let you do that. You back up. There we go. We're gonna watch it. Critique you. All right. So you want to get it towards the top because that's going to be the widest portion. And you have to think logically. Okay, this is really difficult because the manual does not tell you 99.9% of the time whether it's going to be inside or outside or how it wears. So when there's a valve in there, you have to think, how does a valve wear the guide? The valve itself, does it wear bigger or smaller? Smaller. But the valve guide wears bigger. So the hole's going to get bigger. So you want to measure the part that's going to get abused the most. Okay? Because typically on the valve stem, it's the same thing. What part gets abused the most? Well, there's two actually. On the valve stem, it's the part that's right here at the top. as it's coming in and out. And then the other end is the head that's actually getting hit by the rocker. Boom, boom, boom. On the valve face, it's the part that's touching the aluminum head, or the seat. Boom, boom, boom. The seat itself is actually a steel. So you have to think through that. How is it wearing? What's getting worn? All right, tell us what it is.
All right.
Let's get this bad boy out of the way.
I don't know if you can be able to
So guys, let's get this small honker out of the way.
No other locker.
Oh, did you like it? All right, what's our measurement?
You want me to try and show it, or you just want me to give it to you?
All right, we see you. We're judging you. Go ahead.
Okay. So we're past the 4, we're past the 25. We're at 10, 11, 12, 13. Technically, right under
Sound
that.
like case, basically. Technically. Really?
I'm gonna call it 13 because it is underneath. By
13? 13 is that? Yes, it's right. 13 what though? Okay.
So 13 on the 25.
And we can't see. Wait, show us again. All right, we got nice back.
13 on the 25. 38. We have 4, 38, and 9.
Yep. So what's the final answer?
4389.43.
Okay. Right. Yep, good. 0.4389. All right, good job. All right, everybody remember, got a general idea how we're, okay, I don't want you to look at it. It's kind of weird for a second. All right, we have a general idea of how we're using ball gauges, okay? I'm giving a lab out today. If you didn't pay attention, you're gonna be sorely behind, okay? Ball gauge. So when you want it to get bigger, you just tighten it right here, and the ball expands, stick it in till it's just snug. Don't make it ugga-dugga tight, okay? Just snug, and then go the other way, and then get the biggest, the most worn part. You think through it. Which way is it wearing? So if I'm doing a valve, okay, how would I measure a valve? Logically, how would I measure a valve? Even if you don't know the whole process of a valve, you say, okay, it goes inside the valve guide, and it gets rocked open and closed, open and closed. What's actually wearing on this? Well, the face, here, and then right where it goes through the valve guide, right here. So if I measure here, it may be fatter than it is right at the end of the guide where it's got a slight wobble to it. Okay? So right where it gets slight wobble is where you're actually going to measure, because that's going to be the most worn place to determine whether it's airworthy or not airworthy. What I'm not making you do yet is go to the manual, find the number, and then go back and measure it. Otherwise, you would really hate me today saying, we just started this. Eventually, you'll hate me. But right now, don't. We're just learning what the measurement is. I'm kidding. Please don't hate me. But I want you to get a general idea of, all right, how is it wearing? All right, we're going to wear smaller here. Okay, it's somewhere in this area. And you can actually see a line if you look where it comes out of the valve guide. Just take a gander at it and look and say, oh, okay, it's slightly worn right there. So that's going to be our worn spot on our valve stem, okay? All right? The next useful, fun tool that you get to explore with today, and unfortunately, probably the most abused tool we have, telescoping gauge. Okay. Purpose of a telescoping gauge is to measure typically inside the cylinders here. Please don't fall. All right, let me get started here. So this is a telescoping gauge, and here's how they mostly get broken, 2 different ways. Number 1, they're super cool to play with. They just look like a giant T, okay? So you tighten them up like that, and then 2 things that happen is they'll over-tighten them. There's springs in there, so there's a spring here and a spring here. Over-tighten it, eventually it's done, okay? So Don't ugga-dugga it, just tight enough to hold it, okay? And then number two, people love to let them just pop out. And eventually, because it's been tightened so much, the little needle inside that holds them in stops. And then it's really fun. People will find it fun to watch them shoot out in both directions. Okay? We're not doing that, please. Okay? So here's a picture of how you use a telescoping gauge. But what fun is picture? So let's have another candidate come up here and read a micrometer. So let me do it first, and then we'll have you read the micrometer. Okay? All right. So this is a Continental 470. Okay. So the cylinder itself is going to be slightly under 5 inches. You don't need to know that except for when you get to the micrometer. Okay. Okay. So now I've got it inside. I want to get it somewhere nice and smooth. Okay. On a cylinder, there's also a wear pattern inside a cylinder. Okay. Connecting rod goes up and down. So typically, on a cylinder, the most worn position is going to be on the top and bottom, because as it goes up and down, there's a slight rock to the piston getting abused by the controlled combustion explosion inside. Okay, up and down, up and down, up and down. So you can measure it that way. The manuals tell you to do it at a 90. My lab tells you to do it at a 90. So you're going to measure 2 measurements. You will do one like this, like Ryan's doing now. You get it to where it's at, kind of tighten it a little bit, and it's too tight, so that means I didn't get it smooth enough. Okay. Ooh, pretty nice. Okay. All right, so now it pops out. Then we'll get a candidate to come up here and read a micrometer. So then what I like to do is I lay it down, lay it flat like this, so that I'm not playing with the end. Sometimes I even put something underneath the back of it like this, so I can get the micrometer on it to read it. Okay, let's get a candidate here. I have to use the word candidate because it's political season, okay? All right, Pascal, come on up here. I want you to get a micrometer. You'll use the 4 to 5 inch micrometer out of the box. 4 to 5 inch micrometer. The box, yep. It'll be the second from the back. Nope. The big one. Second from the back. If you pick them up, it will say 4 to 5. Good. All right. Let's go up and we'll read it. All right. Here's your telescoping gauge here. So leave it flat. Let's leave it flat like this. All right. Unlock it. And we want to be super gentle. Get it all the way out here. Get it to where it wants to go. I hope you line it up. Okay, so go ahead and move it and get it in. And you want to barely tighten it. This one doesn't have a ratchet, so don't over tighten it, okay? Right there. Hold up. Oh, hold on, it's not straight. Get it straight in there. All right. Hold. see this? See if we can get a little tighter. Oh, almost. All right, so, are we did we reach the 24? No, we're actually right on 23. So 23 plus 75? 98, good math, okay? So, start with our number, 4 inches, right? Point 998, the fourth digit. Nine. 4.9989.
4.9.
9.
8, 9.
Good. All right, that was a lot of numbers. Good job. All right. Well done. So telescoping gauge. So it's used, you could even go down to a very tiny telescoping gauge. Even some of them are so itty bitty, okay? Teeny tiny cuties, okay? And you say, well, what's that for? I don't know what that would be for, Ryan. No problem. That's my job. So, you cannot get a ball gauge inside a rocker arm. This is the rocker. And you say, well, what does a rocker do? Well, it rocks. Okay? It rocks. And so the rocker sits up in here like so. Sorry, I had to look at it a little different way here. Sits up in here like so, and it rocks back and forth and rocks the valves open. So your engine's rocking. You know, you're like, what's that ticking noise? Sometimes it's your rockers just rocking. Okay, valves ticking, rocking, rocking, rocking. So they're rocking back and forth. And inside that is what we call a rocker shaft. It holds the inside. This thing gets crazy abused, okay? Especially those of you like myself who may not change your oil as you're supposed to in your car, okay? So, how do you measure that? Well, I'm glad you asked. You take a telescoping gauge. This is the wrong one. The next size up here, there's a telescoping gauge, and you twist it down, lock it, get it inside, and then release it. All nice and done. Then you come back and check it with what? Micrometer. Please note when we get to rocker arms, there's always a hole inside of it. If you get this inside the hole, it's a useless measurement. Okay? It's called an oil galley. For oil to get in there and to lubricate so your engine's not running. It's like the blood of the engine, always getting lubricated. Okay? So please note that it's not uncommon to have a groove. Hey, Ryan, there's a groove in there and I measured the groove. It was the biggest spot. Thank you, I realize that. But the groove is supposed to be there, that's where the oil goes. It's not a wearing surface. It's a lubricating area. So it may be a slight groove or a hole, depending on how they made it, okay? So the actual round part is what you would be measuring. And sometimes you have to use a small telescoping gauge for that. Any questions on ball gauge or telescoping gauge?
Can you use a telescoping gauge in place of a ball gauge? Like, or is ball gauge more precise?
Ball gauge, especially for like valve guides, because the valve guides are supposed to be pretty close to round and you're checking for out of roundness. Ball gauge is a whole lot better versus this is just two tiny little surfaces you're trying to find.
Because that's small enough to fit in the valve hole, right?
The bigger engines, yes. All the smaller ones, there's not a chance, yeah. Yeah, this is not as, typically not my go-to when I have to do valve guide. Okay? All right, so we have, that would be measured with an outside micrometer. Well, John was asking yesterday, well, what do you do with an inside micrometer? You measure the inside of stuff. Okay, so we're measuring the inside of maybe a cylinder. Okay? Oh, all right, that's cool. So you're measuring the inside distance of it. So it comes out and measures this way instead of from the outside, measuring the outside of something. Okay? or you use a telescoping gauge like we're doing and use it outside the chronometer. Thickness and feeler gauges. How do you use a feeler gauge? I don't think did I bring feeler gauges in? Oh, I did. These are called feeler gauges. Okay. This is a feeler gauge. And they come in various sizes. We do not read the millimeters at Leo. We read the top, okay, inches, okay. The manuals will always give them to you in inches as well. And so here is, what is this component? Does anybody remember what this component's called that I'm holding in my hand? So what? A piston, good. All right, and these on the piston are called piston rings, okay? I'm not gonna go into how they're made or what type yet, but we will. But this is, just for the sake of the lab, this is called a piston ring, okay? Over time, the piston ring gets very, very worn. There are several measurements. Sometimes you'll take the piston rings off. There's a special tool for this unless you have pretty calloused hands. And so then the piston ring actually goes inside the cylinder, and then we measure something called ring end gap, okay? And then what will happen, this one actually doesn't have a gap. The ones that you'll be measuring have a gap because I ensured that they had a gap. Okay? So, inside this one, woo, it's had a rough life, hasn't it? All right, so on this one, you'll see a gap. What is my problem today? There we go. So, right here should be an end gap. And it's usually as small as 40 thousandths. In aviation, that's about what we do. We're not race cars, unless it's a full 14, which has a high compression kit. On our full 14 has a high compression kit. Most of the time, you will have what we would say about 40 thousandths. I've seen them as high as 100 thousandths, okay, or 99, 98 thousandths as they wear, okay. And what does that mean? Well, I'm glad Micah asked, so I'll tell you. What that means is, Micah, you didn't ask, I'm just kidding. So here is 30 thousandths. Here's 30 thousandths. And so when you turn it on its side, the gap there is 30 thousandths thick, okay? And then as we go down, so say you don't have 40 thousandths, what can I do? You can put a 10 and a 40 together. And then right where it starts to go in the end gap there is my 40 thousandths. Oh, it's slightly tight. Then I know my ring gap clearance is 40 thousandths. Another measurement that you have to do is side clearance. Not for this lab, but a common one. And this is always very, very tight. We use feeler gauges for this. So let me use, what's that number there? 6 thousandths, okay, good. And so as we put it in here, sometimes you measure the gap between those two, and it's usually on these pistons, it'll usually be about 2 to 3 thousandths, where the piston, the ring actually fits in the groove. Very, very tight. There it goes. Okay. See how it fits in there, nice and snug?
What is it called? Side what?
This is,
Like that. When you're doing it's called side.
well, this is, it's actually in the manual, they call it ring land clearance. It's not in your lab. I'm just showing you how to use a feeler gauge. Okay. So this is a clearance here, so I'm checking a very small clearance. The one that I gave you today for a lab is using piston side clearance. Okay, so you take the piston and you turn it backwards so the head is facing out, and you stick the skirt in. So it actually goes in. Why is it zoomed in so bad? So you stick the piston and you stick it in the cylinder, and it has to go in. This is a 520 on a 470. So it will go in. And then what you do is, while it's barely in, you take your feeler gauge and you'll measure just the clearance between the piston and the inside wall. That's called side clearance. And you want it just as it starts to get snug. It will be tight. Okay? The skirt is the largest portion of the piston. And so as you put it in, just want to find that. Sometimes the manuals will tell you to use it at the top. But for the sake of our lab today, it's expected for you to just measure at the biggest portion without having to look at the manual. Because some manuals will tell you the bottom, some will tell you the top. We're just going to do the bottom at the skirt edge as it goes into the cylinder and what that clearance is. Everybody understand? Okay? And you do that with what is what is this called? Feeler gauge. Good. All right. Any questions? Any questions yet? Yeah.
Oh, this actually about the telescopic gauge.
Yep.
But when you put that inside of a cylinder, is it technically gonna be just a little bit shorter because it's a flat edge?
That's right.
Is that enough to make a difference?
You mean instead of a ball gauge or what?
Well, like when you're using the telescopic gauge because the edge is flat and you're in a circle.
Yep.
Aren't you gonna be short a little bit?
Yeah, well, unless you get off, and then you'll be too long, like I was when I first started. But then, the lab and the manual always tells you to do it at 90. Try to get an average. If you see a huge average, then you go back and measure it again. So, yeah, good question. You'll be slightly off, but usually, hopefully in the range, pretty close to it. And aviation, we give a pretty wide range, high tolerance. Okay, dial indicator. I'm going to give you an example outside of a dial indicator so that when you are using it, we'll do it in front of the TV in just a minute. Inside and outside calipers. Why do they call them calipers? I don't know. They're called calipers. What do? Well, they don't tell you any numbers. They do the same thing basically like a telescoping gauge does, is where you measure the outside. Okay, I'm going to measure, if it's a valve guide, I'm going to measure the outside or the inside of that measurement, and then the other side you're going to measure the outside of it as it, and then how do I check the inside there? Or how do I check the measurement to know whether it's intolerant or not? A micrometer, good. So you take it, and then we'll go to a micrometer and then check it. The same thing as you did with telescoping gauge. Put the micrometer on it, and boom, all right. That's what the measurement is. These are actually nice. They're spring, and they have tension to them, so they'll actually lock in place. Oftentimes, they may even have a lock nut on it to hold it so that somebody can't bump it. Okay? Another type of caliper is called a hermaphrodite caliper. Okay? It just has one leg that's slightly bent. Okay? Hermaphrodite caliper. So, I think we have one in our shop. But it is an FAA written question, so you know what a hermaphrodite is. Okay, dividers, another word for caliper. You'll see the word in the FA as a divider. Okay. A scribe is another tool that we use. A scribe, you need to take a measurement or line something up. And then combination set. Did you guys have to buy a combination set? Everyone get one? Okay, yeah, good. We'll use it a lot in flight controls class when you start rigging flight controls. Okay, and we'll get angles and measurements and levels. So they're pretty handy to be able to line it up, especially in the construction world too, right? All right. Any questions so far? Very good. All right, how about you guys? Yes?
Somehow we don't have micrometer.
You don't have to have a micrometer. You mean
Right.
caliper?
We are out there measuring inside piston or something like that.
aviation, no. Aviation, really, the only way to get a true measurement is with a micrometer. I mean, even mechanical engineers that I know, a friend who designs car engines, and they're always using micrometers to be able to measure. So it's a very precise measurement. It's usually what you have to use. I don't know how you would get down to 0.49989. I don't know how you'd get down to those small numbers with a ruler. I don't think it's possible. Okay, why don't you guys take about 10 minutes? We're gonna come back. I need your brain flowing, because we're going to do micrometer readings. Womp, womp, womp. Josh, you might as well volunteer first, buddy. everybody done? Oh, no, I got a couple, okay, all right. No problem, take your time. Couple more minutes. And then we'll get our volunteers. Oh, yeah. Well, a hands-on lab, though. All right, we about ready? Very good. All right, let me go ahead and stop the recording so that. All right, so we've already hit the quote of the day. Let's do materials and processes. What is concentricity? Well, a fancy definition for concentricity, which we're throwing the word around concentricity, is a three-dimensional cylindrical tolerance, okay, that is defined by a datum axis, where all the derived median points of a referenced cylindrical feature must fall within. What in the world does that mean? Josh, do you know? Especially on a Tuesday afternoon, you may have an idea what he's talking about? Why do they have to use such big words? You know, what is that called, adult words? Yeah, adult words. Why are we using such adult words? Okay, so let's use crankshaft. This is what we're talking about, specifically crankshaft. So crankshaft comes around and it hits a tow bar. Boom! Bummer. Okay? What's affected? Well, the problem is this is supposed to stay straight. Okay? The moment it gets out of tolerance, you get a vibration. Aviation vibrations don't really go real well because this is steel and the aircraft's made from aluminum. The aluminum always loses. Okay? What does that look like? Broken engine mounts. Someone comes to me and say, hey man, I have a broken engine mount. Why is it broken? Well, there's a fracture. Is it due to vibration? You know, I don't say that out loud to the pilot. It's like, you're sitting there wondering, is it vibration? What is it? Okay, so that when we're checking it, that it is perfectly balanced. It's a perfect radius all the way around each, what we call journal. Okay, so this would be my front journal. You have a second journal and third journal, and this one bigger crankshaft will have 4. Okay, and then even the 720 Lycom's will go to 5. okay? And what is the point of it is that you know all the way along this line, straight datum line, that it's perfectly round. We don't get out of tolerance, okay? So as I begin to turn it around, I use a dial indicator, and it's checking to make sure there's no wobble to it, okay, or that it's very minimal. Because the least amount of vibration or least amount of wobble gives us a long-term running engine, okay? I have a crankshaft here. I'll show you later on in the year. Actually, maybe right here. Let me see if I can grab it. This is what happens when you hit tow bar. On the same style engine that we've been hand propping. This is after about 20 hours after the pilot hit a tow bar. He sells the airplane. I'm pretty sure that's criminal. Okay? Doesn't tell anyone, of course, there's no logbook except for his neighbor who saw it. I know what you're thinking, oh no, there's a witness now. So then they sell it, say, hey, we had a little bump, no big deal, we changed the prop. It's great, congratulations. About 20 hours down the road, there's a clack, 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 clack vibration while it's flying. Okay? Unfortunately, the clank, clank doesn't get quieter. They land, they put a dial indicator to check concentricity with the prop off. Turn it around. It's interesting. It's got a slight movement to it. Huh. Let's go ahead and open the engine. Actually, they did an oil sample first, and what do they find? Steel in the oil filter. Oh no. Okay, let's do it. Let's do it. Sure enough, it was perfectly broken, yet the puzzle still allowed it to run. I promise. 20 hours later. Okay. Did the pilot ever order a run out for a concentricity? No. It is against the law. Once you have a sudden change in RPM, they don't even say stop anymore. Okay, I landed at a grass strip on a missionary field, had a dog chase the prop, okay? Just telling you, it just barely nicked it, but there was no change in RPM, didn't hurt the dog. It did have a little cut on its head, but you watch the RPM, just a sudden change, okay? If it's a significant change, the law says we have to do a concentricity run out or possibly even a tear down of the engine. Never did that. 20 hours later. Thought 10 hours into it, we got away with it. We've not fallen out of the sky, we're okay. Little minute crack, which could have been found the day he did it before he swapped the prop to say, hey, we need to go ahead and do an overhaul. Could have ended somebody's life. Thankfully, they caught it and it rattled and continued running. Rattled really, really loud. Okay? So, concentricity would be going around the outside to make sure that along the datum line, imaginary line in the middle, that it's perfectly symmetrical. We don't have a wobble, 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 out of roundness, okay? The one that you'll be doing today and tomorrow was a prop strike. So I know that it's not round. I want you to see a severe case so that when you find one, okay, this is what it looks like, oh, this is what a bad one, this is symptoms of a bad one, okay, where it looks, okay, it looks like it may have some wear, but what does it look like across the datum line on the dial indicator, okay? All right, yes, sir?
Is that, because I know some props have like a gear system in between. Is that avoided with that?
I mean, the gears,
In the crankshaft?
the gears are still going to get eaten.
The gears will get destroyed, but the crankshaft will be fine?
No, they're still gonna have to all come apart.
It'll break everything? Okay.
Well, not necessarily break everything, but the law says that if there's any sudden change in RPM, so if I drop 75 RPMs and the prop keeps spinning, even though I picked up some dirt, okay, I thought I'd go out and I'd taxi across. This happens a lot where you run off the runway. Oh, I'll just taxi across the grass because I think it's kind of cool, and then you bump an anthill or a little mound. If there's a sudden change in RPM, engine's gonna come apart. Okay? That's only been added in the last 10 years or so, where it's a sudden change in RPM. But yeah, so it doesn't matter, it's coming apart.
Fair.
Okay? Measurement of both the roundness and the position of the crankshaft. So we're checking roundness, but we're also checking really across the datum line to see if the whole crankshaft is straight. Okay? Let me give you an example. Let's use our cute little crankshaft here out of the baby engine. Okay? So here's our crankshaft. And as I get it stationary on the main journals, so main journal here, front, and then I have a middle, and the back one's unfortunately gone. Okay? So now I'm doing a run out, and as I'm rolling it around, if on this journal and on this journal, I see that they're both 60,000, let's do something smaller, 20 thousandths of movement. But they're consistently at the same location. That's interesting. Every time I get number 1 at the top, we have a rise on the dial indicator. More than likely, it's a bent crankshaft along the datum line. You say, well, 20 thousandths is not that bad. 20 thousandths will bring an airplane down in a hurry because our goal is to have a perfectly balanced. Now, maybe on this little guy it wouldn't, but as you can tell, just a little bit of damage could have ended somebody's life. Okay, so 20 thousandths of warpage along the center line, and I have a bent or cracked crankshaft. Crankshaft that we bought for the 470 was $14,800. You know what I call that? Cheap insurance. Cheap insurance. Okay? So if it's bent, don't try to make it work. Send it off. If they can fix it, they can straighten it, they can run it out and balance it, fine. If they can't, drop the 14 because it could end someone's life. Okay? So as you're checking today, just think, man, if I don't catch it, it's more like a detective. When I get kind of excited, I know I'm a numbers guy, but as I'm sitting there watching it, it's like, ooh, was that it? Oh. And I'm looking for anything that would say that's no good, or that might be bad there. And I'm actually trying to investigate, get into it, and say, is this really what it is? Okay. Oh, let's go back. Should double check it? Yeah, it is. So I'll make a little dot, all right, and go over here, check it again, check the front one. Ooh, they're both 20 thousandths off. I probably have a bent crankshaft, okay? All right, we've already done this, but let me give you a definition. A feeler gauge is a tool used to measure gap widths. Feeler gauges are mostly used in engineering or aviation maintenance to measure the clearance between two parts. Any questions so far? Yeah, Isaac?
Do you ever test anything as far as, I'm sure there is, but to check with the dog face, crank, twisted?
Like,
Maybe this is not
no,
there.
you're good. I'm trying to get what you're asking.
Because from small engines, a lot of times, like if something seizes up,
Yeah.
the crank will twist and
Oh,
the
yeah.
dog face. I don't know if that's something.
The most common place for ours to twist now, today, is on the nose. And they'll do that with what we call dynamic balance. That's super cheap. It's like $250. You send your crankshaft out to Aircraft Specialties, and they'll tell you, yep, balance. Or they'll say, hey, we can shave it for $50, $75, and send it right back to you. And I think, yeah, so for $350, they'll tell you, hey, your crank's balanced or not, and they can balance it. So that's, you're talking $70,000, $80,000 engines. So that's cheap. Yeah. Good. All right, one other tool real quick, and then I want to go out in the lab and show you something. So referred to this as a dial bore gauge earlier. Okay, this is the same cylinder you'll be using. This is a dial bore gauge. Okay, inside, if I wanted to measure the inside of this, Parker, what would I use to measure the inside of a cylinder to know what's the inside diameter? Telescoping gauge. Okay. And then what would I use to check the telescoping gauge? Micrometer. Good, outside micrometer. Okay. Now, this is one young lady. I'm not going to tell you her name. Did a engine for the class a couple years ago, and put chrome on chrome. Okay. This is what death looks like to an engine. Okay. Why can't I show this? Work with me here. Why does this hate me?
You want a flashlight?
No, I don't know what the deal is. Okay. All right, so you see the deep grooves here along, going up and down. They put the wrong type of rings inside of it, and it was bad. So, over time, these cylinders get very, very worn. Okay, this is a dial bore gauge. Dial bore gauge. Can anyone tell me to what unit of measurement it will measure? Tenths, hundredths, thousandths, 10,000ths, right there. Okay, so each tick mark is how many? A 10,000. Okay, so the way this works is it has a little button right here on this, right in the middle. These are alignment points, and they're rounded, and then it's very sensitive. So once you know the size of the cylinder, it will move so. Barely pushing it, it will move. Okay, so once I have my cylinder set, and a lot of times they'll set it in a micrometer. Okay, I use a telescoping gauge, I get the inside size of my cylinder. Okay, if it's a 470, it would be 4.998 or somewhere around there. Okay, so then I'll take a micrometer and I'll set from here to here 4.998. Okay, this is, I can't tell you it's your lab. Can't tell you what size it is, okay? So you go ahead and set this, okay? It's super easy. You just use the lock nut here on top. Don't mess with the bottom ones. And then once it's locked in, you lock the lock nut. It's ready to go. And then as it goes in, just like this, you leave the top one up. Let's see if I can get this backed up just a little bit. Okay, and then this one comes in. Almost. This cylinder's really rough. All right. Can you see the dial indicator? Okay, so on this one, the dial indicator, your goal is to move very slightly. Okay? A lot of times you'll see people, you can actually move it to a 0 mark just to give you a better number. Okay? See how every little movement, how it moves? Every little movement. lined up, and my goal is to go back and forth. This one has deep grooves, so it should be bouncing, jumping a little bit. See that? What if I'm worried if it's me or the tool? How can I know for sure that it's the cylinder, not just me being jumpy like this? You know? Ooh, look at me moving. How can I be sure? Yeah, even simpler though. Just double check. Go back over it again. You're like, oh. I know you guys are like, oh man, that was way simpler than I thought. Just go back over it again. Oh yeah. See how consistent that number is right there? You got a pretty good jump each time. Wow, that's a pretty good movement. It's about 5 thousandths. Okay, so the goal is not to be checking in and out, okay? You can do that, but as you're going around it, you're looking for worn spots as it goes around, okay? And what I do with my left hand here is I'm just kind of keeping nice position because the actual bore gauge itself is slightly off center. So I just have my hand against that. Okay? And you're actually able to check for out of roundness just at a small portion. Usually just 20 degrees or so, and then pull it out, or you can turn it and do it at another 90 there. You guys think it's worn? Super consistent as far as how much it jumps. Okay? You say, well, it's not zeroed. Fine, but I can count 10, 20, 30, 40. Okay? It's moving about 30 degrees or so. Okay? Let me get back stationary here. Man, I'm getting home too. Okay? So then I know, all right. Now I go to the book, and the book says, hey, you're allowed 10 thousandths out around. Would this be legal or not?
No way.
Okay? Even if I found one spot in the cylinder, guess what? It's gone. Okay? All right? We're looking for, all right, is it within the minimum? Nope, it's out. Okay? All right, everybody clear there? This is called a what? Dial bore gauge. This is called a ball gauge. Yeah, yes, Josiah.
If you were to hone that out, like, how much of that could you fit the lithium?
That one you will never fix. It's chromed already, and then, so actually they'd take all the plating out, re-chrome it, or just buy another one, okay? Unfortunately, those old 40s, that's a 40, let me look at it real quick. It'd be a 46 probably, 45 or 46. Nope, 57. 57. So I doubt you'd get these anymore. They probably would have to re-chrome this one. These are hard to find engines. Okay, why don't you guys take about 7 minutes and then meet me in front of the TV out in the lounge, okay? 7 minutes.